Good afternoon, everyone. Thank you for making the choice to attend this session. Today, we're going to talk about a few things, and mostly confidential computing, and of course, other customer examples as well. So my name is Sam Lugani. I look after product management for confidential computing at Google. With me is Danielle, who heads product security at NVIDIA, and Ranjit, who's our engineering leader for confidential computing at Google. Let's get started. Today, we're going to talk about the AI revolution and how confidential computing is becoming that perfect enabler of AI growth. We're also going to talk about real customer examples of how organizations are using confidential computing to unblock use cases which were really hard to accomplish earlier. We're in this new chapter of confidential computing, and the inflection point has been our embrace of AI. Now, we need to use AI in a privacy-preserving way. So there's the data aspect, the data that we use within AI systems, that has to be protected from things like unauthorized access, poisoning, and any sort of manipulation. Because that data can include financial records, it can include healthcare records, and we need to make sure that data is processed in a privacy-preserving way. And then there are the models and the weights themselves which need to be protected. So the great AI momentum that we're seeing is intertwined with this need for confidentiality, with this need for verifiability, and this need for isolation. And that's where confidential computing comes in. So when you look at confidential AI as a paradigm, it layers these key tenets of confidential computing as part of it. So there's confidentiality because the workload itself is confidential, encrypted. There's isolation because the VMs are isolated against other VMs on the same machine, as well as the hypervisor. And then there's integrity and verifiability as well. And all this works out through attestation because we ensure that the workloads you're running aren't tampered with in any way. And you can verify that the environment they're running is actually confidential. So with all this, you can run inferencing, training, agentic workloads in this trusted execution environment with guarantees around confidentiality. Now, AI Genomics is one of the companies which is doing something really unique on the healthcare side and embracing confidential computing in its true way. They are developing solutions for something we call as AMR, antimicrobial disease resistance. So what happens is that when folks get admitted to hospitals for, let's say, a surgery, they get treated with a roster of antibacterial drugs and antivirals. And over a period of time, they can develop resistance to those drugs, which results in suboptimal patient outcomes. So what they're doing is that they're collecting data from a lot of different entities, processing this data in a privacy-preserving way, and giving outcomes onto, for example, things like, well, here's a patient, this is the antibiotics they've been treated with, what's the precedence of them developing any sort of antibiotic resistance, so that measures can be still taken to better those patient outcomes. So it's an example of how confidential computing is impacting us indirectly or directly in our daily lives as well. Jonathan Monk is the head of bioinformatics at AI Genomics. Let's hear what he has to say.
AI Genomics provides deep epidemiological analysis, linking strains to investigate outbreaks with precision. But the most informative reports often require the most sensitive data: patient age, travel history, and lifestyle factors. AI Genomics customers asked for uncompromising privacy, and AI Genomics delivered. Last year, we shared a vision for a more secure cloud. Today, it's a reality. The entire ID AMR platform now runs on Google Cloud confidential VMs, ensuring that data is encrypted even while in use. In addition, AI Genomics is able to protect its AMR algorithms from misuse and preserve IP. Our next step is to start using confidential space. This allows for securing processing in the cloud without ever uploading data to AI Genomics servers, protecting both customer-sensitive information and our proprietary algorithms. IDAMR isn't just a pathogenomics platform. It's a secure ecosystem where innovation meets absolute privacy.
And Oppo is another company. They're a big hardware manufacturer, electronics manufacturer coming out of Asia. And they're using confidential computing to ensure that their customers have a privacy-first AI experience. So they're creating this whole private compute cloud on Android, which is powered by confidential compute. Google Ads use this confidential computing in a very meaningful way as well. They have a product called confidential matching. Let's take an example of what that is. So let's say we go to a website, CNN.com, for example, and browse a few articles. At that point, CNN.com has a fair idea of your interest, what you're looking for. Google Ads has first-party data on you based on your search history, for example, as to what your interests are. The right ad to serve to a specific person is going to be an amalgamation of these two data sets. But these two entities will not be willing to share these data sets with each other. Confidential matching makes it possible by using confidential computing at its core. Jayant is part of the team that has built confidential matching in Google Ads. And here's a quick demo of what that looks like.
Take a look at the data manager demo running behind me. You'll see how we are solving a complex fragmentation problem. Your data might reside inside a CRM, a CDP, or a native cloud data warehouse, but the security posture always remains same. The breakthrough here is how we leverage confidential spaces to act as the ultimate clean room without any complexity. As the demo connects these various sources, it's preparing to move data into a hardware-isolated environment where you are a developer or a multinational company or a small business owner. The process is built into the premise that no one, not even Google, has access to your raw PI during the matching process. This is the heart of our technical narrative. Notice how we actually set up a worker identity pool and integration with the GCP key coordinator service. This isn't just encryption at rest, this is true confidential computing in action. As the analyzer connects and maps their various fields, Google Ads gives them privacy by default and creates that pipeline behind the scenes. All of this with a few clicks of a button.
And next, I want to talk about Cohere. I'm very excited that they're using confidential computing as well. They're building these state-of-the-art foundational models for their customers, and they rely on confidential computing to ensure private AI processing for their data and to protect their models as well. They're actually using confidential computing on GPUs, H100s, and helping their customers process the proprietary data that they have and make sure that the customers have the trust they need to use these models with Cohere. Symphony is another example. Now, Symphony serves as a central communication hub for global financial institutions, and they process millions of mission-critical messages every day. They are using a product we call as confidential space, and with that, they're creating the secure digital vault, trusted execution environment, where all these messages can come in and be processed in a privacy-preserving way. And in that process, they're not accessible by anyone, including Symphony themselves. So it is this total confidentiality that helps financial entities trust Symphony and their messaging system. Now, in some of the examples we spoke about, we spoke about confidential space and organizations that want to accomplish data collaboration without actually sharing data. So they want to retain data ownership, yet share data with each other, collaborate on data, and share the outcomes. And that's exactly what confidential space helps do. And here you'll see the spectrum of confidentiality. So with confidential VMs and confidential GKE nodes, you have protection against the privileged cloud admin. With confidential space, it takes it one step further. It builds on the base we've built with confidential computing, and it adds protections against the privileged customer admin as well, such that the operator, the workload owner, can also be outside the trust boundary. In addition to the other verifiable entities it has around attestation for not just the environment, but the workload as well. We're not just, it's not just our customers using CC. We're, internally, we use confidential computing as well. It is something which we're using for critical services inside of Google. And over the last few years, we've rolled out hardened VMs backed by confidential computing. So today there's many sensitive services that are protected by confidential computing at Google. And let's talk about Pixel. So the most effective AI doesn't just answer the user's query. It predicts what the user wants based on the rich context it can gather. But this context has to be processed in a privacy-preserving way, and that's where confidential computing comes in. Pixel Private AI Compute is also using confidential compute for these outcomes. And then there is Google Distributed Cloud as well. This is for organizations that want to extend cloud infrastructure into their own data centers. Think manufacturing, think public sector, and they have their own very specific needs. For example, there's low latency requirements. There are requirements around regulation and around survivability as well. And not just that, they also want to run Gemini inside those environments. So how did we really make Google's most valuable intellectual property accessible to customers directly on their premise and running on their own hardware. And you probably guessed it right, confidential computing powered that as well. So overall, what does our confidential portfolio look like? We've set the foundations with confidential VMs across Intel hardware, across AMD hardware, and with NVIDIA GPUs. Then we've built services on top of that the way you can enable confidential computing. GKE, Dataproc, Dataflow, Vertex Workbench. And then there are applications such as confidential space that help with secure collaboration and data sharing. Now, across all this, a very, very important key tenet for us has been to make confidential computing easy to use, because that's the core tenet of accessibility. So let's take a look at the Google console. Right alongside, we now have the Gemini Cloud Assist box, which can help answer questions. So for example, in this specific case, I'm looking for compute-intensive workloads. What's the right machine family for me to use for confidential computing? As it's looking at my request, I start spinning up a VM. So the moment I click on security, I'm presented with a couple of options. I can enable confidential computing with that single checkbox. It presents me with different flavors of confidential computing. There's AMD SEV, AMD SEV SNP, and TDX as well. And I can pick the one that best fits me. Now, Gemini has finished its inferencing request, and it says the C3, which is an Intel-based machine family, is the right fit for me. So here I can just choose Intel TDX, and it automatically defaults me to the C3 machine family where it can be enabled, and all I need to do is to press create and start the whole process. Or I can actually go back and look at some of the other options I have for GPUs. So in this specific case, I can click on GPUs, and we have the H100 GPUs that support confidential computing. So I'm picking that. It automatically defaults me to the right configuration with one click, which is the 1G configuration in this case, and I press create. And there you have a confidential VM with GPUs on the A3 machine family with H100s enabled. So it's as simple as that at its very, very core. Now, our journey is continuing. We're on this mission to have confidentiality everywhere, a future where data across many services can remain protected even while it's in use. So we have some new announcements to make. Very, very happy to have confidential C4 in private preview with Intel TDX. This is powered by the 6th gen Intel Xeon processors. It also includes support for AMX, which is advanced matrix extensions for CPU-based inferencing. We also have live migration support for C3D, globally available, and this runs on AMD hardware. And then we have the prompt encryption SDK in private preview for encrypting your inference prompts. And Ranjit is going to get into more details on that later. So as you look at the confidential accelerators portfolio that we have today, we have the Intel Xeon Gen 4, Gen 6 machine families, the C3s and the C4s enabled with TDX. They also support, again, AMX, which is for CPU-based inferencing. We also have confidential VMs on A3, which is powered by NVIDIA H100 chips, and that is in general availability. But there's one more thing, and I often get asked this question: how and when are we going to make confidential computing accessible and available to everyone on GPUs? And the answer is we're doing that today. So I'm very, very excited to announce that we have confidential computing available on the G4 machine family, which is the NVIDIA RTX Pro 6000 GPUs, which is paired with the AMD CPUs. This is the first confidential Blackwell platform to be available globally with minimal performance impact. And this is a big deal for us and close to our hearts as well. I remember, a couple of years back, NVIDIA and we guys were sitting in a room trying to figure out what's the real way to democratize the access of confidential GPUs. And we landed on RTX Pro 6000. Can we make it available for everyone at the right price point with minimal performance impact, available in every region GCP has G4 in? And we have done that with confidential G4. So it's an incredibly proud moment for us, and no better person than Danielle, who runs product security in NVIDIA, to talk about what we've done together and to talk more about RTX Pro 6000 and other GPUs.
Thank you for that lovely introduction. I will say, a repeat offender here at Google Next. I think this is our 3rd year up here talking about confidential computing, and delighted to be here again with everyone. This has definitely been a journey, and Sam rightfully highlighted, we've been partnering with Google over many, many years on this. I think we, well, certainly NVIDIA started in, I think, thinking about AI in 2012. We saw this AlexNet, this little image classifier program, went, wow, that's really interesting. And while many people are like, oh, this is really good for solving image classification, NVIDIA came away with this observation that if you have enough data, you can convert almost any problem into a dense parallel application. And for us, it wasn't just about image processing, it was about all applications. And for many, many years and many decades, working at NVIDIA, we were always looking for applications that could benefit from parallel computing. And what we learned that day was every application was parallel. I didn't have to go for applications, they would come to me. And we started building out our AI roadmap of how do we enable this. And very early in that roadmap, we realized, hey, it's about the data. And in order to realize the true value of AI, we needed to be able to overcome this reticence to access data, your most important data, your industry and your company's most valuable data, and put it in the hands of a cloud provider or some other enterprise. And that became a real barrier. And our first inception around that was to look at a model for confidential computing. And serendipitously, I happened to be in the hallway with some Google friends when we were thinking internally about this. And they made some words out loud that made me think, oh, they're thinking about the same problem. And we had a very quick conversation and realized from a chip that we were talking about in 2021, we launched late 2022, and in early 2024, we had a full production confidential computing solution with Google in the cloud. Amazing. But even at that time, we already knew the scales were going to be in trouble. We're on this AI hockey stick. We're looking at models that have grown just in the last couple of years, 10x in size, going from simple LLM agentic sort of interactions to full VLMs doing audio, video, multiple languages, image processing, as well as the native LLM dynamics. We're seeing token growth on the order of 100x going across this cycle here from perception AI to generative and agentic, where generative AI, long context thinking, 100x the token rates. We've got agentic claw bots that are running 24/7 operating on token streams to produce business intelligence. And then we've got new markets growing, and we've got physical AI growing. Now we're doing sensor arrays, dynamic simulation, AI modeling. We're talking about a 10,000x demand in tokens just in the last 2 years. So Hopper, fantastic, great workhorse. Even when we launched it with Google, at the time we knew we weren't there yet, right? We still had a lot yet to go to remove barriers to market, right? Because at the time, there were only certain models that would fit in that H100. And we knew there were newer models that we wanted to run right now, that we couldn't quite get there. So we doubled down, we went after Blackwell product architecture, and we see 2 releases today, the RTX Pro 6000, we have the A3 H100s, we have the A4 and A4X Max, which is the B200, B300 solutions here as well. Walking up this curve, and you can see this multi-GPU, and announced today also Vera Rubin, I think with Google as well, coming to the fore, which is our full rack NVL72 solution, and NVIDIA even has ambition to do a whole data center confidential computing as a cluster, and it's really to remove barriers to access, remove barriers for using this fundamental technology to protect our workloads, to protect our data, because it's all about the data now. Everything that matters is driving data, these models, these work streams through these systems, and making sure we can protect it soundly, end-to-end, all of the time, everywhere. And important on that journey, we can get the slide to go. Hello. There we go, performance. This comes up. So what was the trade-off? Well, before beginning, we couldn't get models in because they were too big. The barrier was the model size, and then it became performance on the model size. So B200, B300, we doubled down. We have full NVLink encryption across 8, so you can get frontier model sizes. This DeepSeek R1 is our representative frontier model in a GPU at 95+%. Very little trade-off for CC. For RTX 6000, which I don't want to double down here, because in case you didn't hear it, it's available globally. There was a barrier to access for some users in some workloads, maybe in the EU or others, were like, hey, I can't run that in the US, or I have some data transit overhead that I just can't absorb pushing it across that region. Now it's available locally everywhere. So RTX 6000, 1%. We're measuring on a a variety of representative open weight models. We've got closed weight models too. You can talk to your partners of those closed weight models, what that looks like. But Llama 7B, 70B, Mixtral, Quen, 1%. There's not a trade-off here anymore. The question should be not if I should be using confidential computing, but why am I not already using confidential computing? Because it's about your data. How do we protect that data? And certainly we've seen a lot of markets across this journey of we're now on our third generation with NVIDIA confidential computing technologies. We definitely started in the financial and healthcare verticals, highly regulated. You saw case studies here from Sam earlier today about how they've been partnering with folks in this space to enable this. But we're seeing a lot more motion around public sector and regulatory regimes because it's data, and it's data all the time. Now everyone has a data privacy concern. They have a data regulatory concern. Increasingly, that is foremost in people's minds, and finding good ways to protect data to meet those regulatory burdens. Confidential computing is a great asset for that. We're also seeing sovereign AI. Regionally, you need to exert some control. We're seeing solutions. NVIDIA has plenty of solutions. Google is coming out with solutions. Google Distributed Cloud, you heard talk about. You can run it in your own region, in your own data center, if you need to. So now it's really about when, how, what. And we're just systematically eliminating every single barrier to being able to use this technology to secure your workloads. And model protection. Ironically, when we first started on this confidential computing journey, we were looking at how do we get the data to the model. And it turns out there's a lot of investment in IP that is now going in these models, and the question is, how do I get the model to the data? And while we didn't anticipate that direction initially, it turns out all the same controls that you need to protect the data going to the model work for the model going to the data. So Google Distributed Cloud, you can see models at the edge. Gemini is available at your enterprise. I know we run it internally to NVIDIA. Fantastic to have these opportunities, because then it's really putting you in control of your data, you in control of your workload, all the ways that matter. I do want to highlight, and again, sort of in the vein of systematically removing barriers to access, there are lots of different ways you can run a CC workload. Turns out confidential VMs is probably the most common. It's the one that first came out. But a lot of AI workloads tend to start in containers. And we support both Kata Coco. It went EA earlier this year. We expect it to be GA in a week or so to make confidential containerized versions available, again, removing a barrier, as well as the many, many versions of confidential VMs that you see today across the Google and public portfolios. So really great improvements. And again, just by nature of all of the partners, Intel, AMD, Google, NVIDIA, systematically working with the ecosystem to remove barriers to make this technology as readily accessible, as easy to use, no compromise, every day. Just looks like a normal workload, because it is. Every workload is AI, and it's all driven by your data. So the goal today, really top of the line, how do we build trust? We need more trust. We need more control. We need more data access management. Confidential computing is a fantastic foundation for that. We're hearing the story from our partners. We're hearing the stories from our customers about the need for this. We have verifiable trust through the hardware primitives confidential computing provides. It allows you to verify the workloads, so you know what you're running, where you're running it, how you're running it. We're removing barriers to access, both performance, model scale, workload types along the way, and we're also scanning for future demand. We talked about what Blackwell is today. We see where Vera Rubin is going, full rack scale model, and we anticipate building that all the way out to the data scale. So there's really, now's the time. We're in the moment of inflection for AI and agentic workloads. If you haven't investigated confidential computing, or this is the first time you're learning, please reach out to us. Please reach out to Google. They will educate you and help you find a path to get your workloads running right now, because it's ready. Ranjit.
All right. Thank you very much, Daniel, and good afternoon, everyone. As we head into this last section, I'd just like to take a few minutes and walk us through the details of 3 critical aspects that we should pay attention to as we build out a confidential AI-based solution. Confidential VMs, confidential GPUs, as we've heard a lot about, and what it takes to secure user data and user prompts and responses end to end. Now, first, let's take a look at confidential VMs. Now, what makes this confidential as opposed to a regular VM is that your guest memory is encrypted with ephemeral per VM specific hardware keys that are managed by the CPU. Now, this gives your workload much stronger protection from anything that is outside of the trust boundary. This includes the cloud provider, it includes the host OS and the hypervisor, it even includes infrastructure admins. Now, along with confidentiality, as Sam also mentioned, CVMs or confidential VMs offer workload integrity. Now, what this means is that unauthorized code or data modification is going to be either detected or prevented from anything outside of that trust boundary. And so what we know here is that only untampered code and data is going to be operated on within this environment. And finally, what gives all of you the confidence that you actually are running in this environment? You can verify all of this through hardware-rooted remote attestation. Now, we support, as Sam mentioned, all of this on both Intel and AMD CPUs today, with support for ARM as we go forward as well. Now, let's move on to the second aspect, GPUs. Now, in a typical VM that has a GPU attached, as you'll see here, the communication between the CPU and the GPU is unencrypted. What this means is that the host OS, the hypervisor, all have full access to what is running on the GPU. Now, to ensure that your model and your data are protected, we build on CVMs with confidential GPUs. When you pair a confidential VM with a GPU that is running in confidential mode, all communication over the PCIe link is encrypted between the CPU and the GPU. And this is done by the GPU driver that is running in the guest through something called an encrypted bounce buffer. In addition, as Daniel also mentioned, in some cases you have up to 8 GPUs running on a particular system, and all data between those 8 GPUs is encrypted over NVLink as well. And all of this is done completely transparently the moment you enable confidential compute. Finally, we also get cryptographically asserted claims from both the CPU and the GPU that allow you to verify the properties of the environment that you are going to run your sensitive workload on. Now, this is a powerful system, right? You can run your demanding AI workloads with all the protection that confidential compute brings to the table. And as Sam mentioned, you can do this without any application changes with a simple click of a button. So we've talked about confidential VMs. We've talked a little bit about what makes confidential GPUs protected as well. But there's also data that is exchanged between your client application that you're giving your users and your inference workload that is now running in this secure environment. All of that also is protected or should be protected. It is sensitive data as well. There could be user-generated prompts. There could be responses that all contain potentially sensitive information. Now, as Sam mentioned as well, we are introducing today our confidential compute-based prompt encryption SDK that helps you protect all of this data that is running between your client application and your inference workload. Now, this SDK takes care of establishing an end-to-end encrypted and attested communication channel between your client application and the server workload, protecting that last mile gap as well. So let's take a minute here and just dive into exactly how this is going to work. Now, the first step that we do here is the SDK generates a set of instance keys. This is essentially an ECDSA public-private key pair. This is done by the server SDK that you integrate into your customer workload. Now, this inference workload is essentially going to use an OIDC token to be able to prove its trustworthiness to the client application. In order to be granted this OIDC token, there is first an attestation verification flow that happens between the inference workload and an attestation verification service. Now, the server SDK gathers essentially attestation evidence from the CPU, from the GPU, and from your workload, and provides that to this attestation verification server. And once that attestation is successfully verified, the workload then gets back an OIDC token to allow it to continue the process. Now, we're finally at the point when the client is ready to connect to the inference workload. And in step 3 over here, the client essentially establishes a regular TLS channel. This may probably go through a bunch of intermediate nodes along the way as well. Now, once this particular TLS channel is established, the client and server SDKs independently generate what is called the exported key material, or the EKMs, that will eventually be used to verify these TLS endpoints. Now, in step 4, the server SDK packages the OIDC token, the instance public keys that say this is the machine that I'm actually running on, and a session signature over them, and sends them over to the client. Now, the client SDK receives all of this attestation data, and it executes a multi-step attestation verification process. First, it has to verify that this OIDC token that it received from the server is actually a valid token. Once it verifies that, it cryptographically knows that this server is indeed running in a trusted execution environment. Secondly, if the signature verification over all of this data that is sent by the server passes, it also knows that the application server is actually the one that is sharing the same active TLS connection that it is getting all of this information from. And this prevents man in the middle or replay attacks. Now, once step 5 is done, the connection at this point is considered secure, and the client can then start exchanging prompts and receiving responses back. Now, we've talked about all of these 3 things, right? Confidential VMs, confidential GPUs, and now prompt encryption. All of this adds up to provable privacy. And we've made it very simple and very easy to use. Confidential VMs and GPUs, as you've heard about, all it takes is a single button that you click to enable your sensitive workload to run in these environments. And how do you get all of these prompts and responses protected end-to-end? A very simple integration with the prompt encryption SDK. Now, let's bring all of this together and maybe just see what an actual example would look like. And in order to maybe set the stage for this a little bit, I'm just going to pose a simple question. What would it look like if you had timely and private access to your own personal medical information? How would that redefine what personal well-being means to you? Now, especially in today's world where all of us are pretty much running nonstop and time is at a premium, I would think that this would be a game changer. Now, with this rough example here, I'm going to walk through how we could build something like this with all of these pieces of technology that we just talked about. Now, let's imagine that I have a medical provider that I'm a customer of, and that provider already stores all my patient information. It's got my health records, it's got my lab reports, it's got all my doctor's consultation reports there as well. Now, to enable me as a customer to get private, timely, useful information from that medical provider, let's just say that this provider has also provided an AI assistant, some kind of a AI-based chatbot over all of my medical information as well. Now, in a non-confidential based workflow, there would be an inference server that is running essentially unprotected on an unprotected VM. And all my prompts and responses back and forth to that inference server would essentially be in the clear. So step 1 here would be encrypting all of this data at rest. So my private information encrypted at rest. And this is something that Google does by default. As a second step, we can bring in these confidential VMs and GPUs that we just talked about as well, along with verifiable attestation of these environments here. And this will allow my provider to know that they are running their inference workload in a protected, secure environment on a shared cloud, which is very important. And finally, we'll add the encryption of prompts and responses all the way to the TE that is running in that protected environment. And this allows me as a user to know that my data is protected end-to-end as well. Now, to see this in action, let's just take a quick look at a demo in here. I'll show this on our recently announced confidential G4 platform, which is running the AMD SEV CVM with the NVIDIA RTX Pro 6000 GPUs set up in confidential mode. The client application and the inference workload have also integrated this prompt encryption SDK to help establish that end-to-end secure channel. Now, as we go backstage, let me show you the VM that is set up as a confidential inference backend over here. You'll notice that this is running a standard GCE G4 AMD system, but with confidential compute turned on over here. So you'll see in a minute, the confidential VM service is enabled here as well. In addition, I also have the RTX Pro 6000 GPU that is set up in confidential compute mode. Now let's look at that demo scenario once again. Let's say that I, as a customer, am engaging with my medical provider, right? And that's the flow that we'll just use as an example to walk through today, through maybe an unimaginatively named medical assistant application. Now, my provider has set up a policy that requires certain confidential compute-enabled hardware and software. So you'll notice here that those two systems that we talked about earlier, SEV and the RTX Pro 6000, need to be enabled in confidential compute mode as well. Now, in this first example, let's say I'm talking to a server or an inference server that is not running on this confidential backend. This could be accidental, it could be malicious. What you'll notice here is that the attestation verification has failed, and I, as my client, I'm not able to verify that this is actually running in a confidential environment. This client is now preventing me from connecting to that backend. It's also disabling the prompts. This shows the power of verifiable attestation. Now, let's go to the second scenario where, in this case, my client application is connecting to an actual confidential enabled backend. You'll notice here that the policy remains exactly the same. I'm still looking for these environments to be set up correctly here. In this case, when I connect, you'll notice that the connection is successful because the client has been able to verify that both the CPU and the GPU on this particular machine that the workload is running on is a confidential enabled environment. I am able to connect to the confidential backend, and I now can check for timely information that allows me to cross-reference my current conditions with my medical reports that I have stored on my medical provider as well. So let me just tackle a scenario that is probably very familiar to all of us here today, right? I've got a whole bunch of walking to be done, and I want to make sure that I'm set up well for success over the next couple days and here. Now, what you'll notice here is that the assistant has processed my medical history. It has cross-references with environmental data here, and it is giving me clinical device. And all of this information is going back and forth in a secure, protected channel as well. Now, no telemetry logs or model trainers or even my cloud provider will know that I sprained my ankle last month. Now, I've done my 20K steps. Let's say I'm faced with a tough decision at dinner tonight, right? Chocolate lava cake is something that we should all be enjoying, but maybe not too much, right? So now I'm going to go back to my assistant, and you'll notice here that I've asked this AI assistant to analyze my critical medical information. I've asked it to go pull information from what is from my lab reports, from all of my medical history over there, cross-references with data here. So very private, very sensitive information, but I'm able to get timely information that goes back and forth. Now this, I think, would be the holy grail of personalized healthcare. The assistant has linked all of the physical activity that it is seen right now with real-time, highly relatable dietary information or dietary decisions, utilizing all those sensitive lab records. Not anything that I would want to have out there in the open, either with my cloud provider, with any of the intermediate nodes, and certainly not with folks that are just out there looking for stuff to attack. Now, this is the power of confidential computing. This enables use cases that would not have been possible earlier. It enables use cases that hopefully make all our lives better as well. Now, to wrap up our session today, we've covered 3 critical aspects that go into building a confidential AI solution. We've talked about confidential VMs, confidential GPUs, and setting up a secure channel that enables my prompts and responses to be protected end-to-end as well. In addition, there are a number of building blocks that, as Sam also quickly highlighted earlier on, that we are providing customers to help you build all of these sessions together. Number 1, all of these are built on the strong foundation of a hardware-backed trusted execution environment that provides confidentiality, integrity, and verifiability. Secondly, all of this foundational infra is then extended with core GCP services that are also confidential compute enabled. And finally, we've got a set of broader building blocks that enable you to build solutions on top of these foundational capabilities as well. Now, confidential compute, if you look at it, is both an unblocker and an accelerator. It helps us to unlock the power of AI in a privacy-preserving manner. Now, we'd love for you to continue your journey here at Next. There are additional sessions that get a little bit deeper into some of the topics that we covered here today. I'd love for you to be able to visit those if you do have the chance to attend some of these sessions. We also hope that you've enjoyed this particular session, right? We wanted to make this as relatable as possible, which is why we looked at what it would take to make some real-world demonstrations and examples that hopefully will resonate with all of us here today. We'd love to hear from you as well. With that, thank you very much. Sam, Daniel, and I will be more than happy to chat with you if you have any additional questions. And in the meantime, hope you have a wonderful rest of the day and the next sessions at Next as well.